Okay. At the top.
Wait, there's a place where I'm supposed to sign in. I signed in on that one in class.
Just there. Wait, the clipboard you signed in
I signed
on?
in class.
Okay, then yeah, it'll come around. You just sign it. Or sign it after.
Oh,
Yeah.
yeah.
Okay, parallel functions. What do they have that's the same? The same slope. So remember, if they have the same slope, then you need to set the derivatives equal. Good job. Good, so on your grind. Okay, so if you want to find the x where those equations are, where their tangent lines are parallel, then you need to take each of the derivatives and then set them equal. So what will f prime of x be and what will y prime be? Yes, and what's the derivative of negative 2x? Okay, so the derivative of negative 2x is negative 2. And then the derivative of ln x is 1 over x. Okay, then for y prime, what's that one, the derivative?
1/4.
1/4. Okay, remember, if it's a line, it's just the m, or you can take the derivative either way. Okay, from there, we're setting those equal. So negative 2 plus 1 over x equals 1/4. What's our next step? Add the 2 across. And if I'm going to add 2 to this side, how could I write it? Instead of a 2, well, so yeah, it'd be 8 over 4, but then when you add the 1, it'll turn into a 9. So I add my 2 across, but then I change it to 8/4 so that it combine with the 1/4. So then I have 1 over x equals 9 over 4. And then remember that if you reciprocal one side, you can just reciprocal the other side. So 1 over x flips to be x over 1. 9 over 4 flips to be 4 over 9. So that means that x equals 4/9. Their slopes are exactly the same. Okay? Alright, go down to number 2. So it says h of x equals blah blah blah. The tangent line of h at x equals 2 is parallel to the line that contains the points 1, 3, and 4, 15. What is the value of k? Okay, so h of x is this. And we know that it's parallel to the line that contains those 2 points. Now, if I want to set their derivatives equal, I can't do that if I have 2 points instead. Can you still, though, do something with those points? Yes, not even really that much. What do I need from it? Not the whole tangent line, just the slope. And so you'd use your slope formula from Algebra 1. Or rise over run if you like that better. So I'm going to find the slope here. Remember, that'd be y2 minus y1, x2 minus x1.
14.
Okay, good.
12.
So it'd be 15 minus 3 over 4 minus 1. So that'd be 12 on top, 3 on bottom. Okay, so now think about if the slope between my lines is 4, so I'll put slope equals 4, and I know that this has to be parallel, then what am I going to do with my equation? Okay, guys.
Take the derivative.
Take the derivative, set it equal to 4. Okay, what is h prime of x for that function?
3x squared plus...
What are you going to do on that one? Multiply the 2 down, now it's a what?
2k.
2kx. And then remember, I want this slope equation to be equal to 4. Now, that has too many letters. What else did they give me to help me find k? Look back at the question. Where are they supposed to be tangent? At negative 2, right there. So you're going to let 3x squared plus 2kx equal 4 at x equals negative 2. And then we're going to plug that in. So 3 times negative 2 squared is 3 times 4. 2k times negative 2. And then you would just kind of keep solving from there. Okay, so remember that slope between points, you can still find it. If it's an equation, you're taking the derivative. So 3 times 4 gives me 12 here. This is going to give me negative 4k. What would my next step be from there?
Subtract 12 on both sides.
Subtract the 12. 4 minus 12 gives me negative 8, and if negative 4k equals negative 8, what's my last step? Gonna be 2. Good. Okay. So just keep in mind those multiple representations. You could be taking slope between points or taking the derivative. Okay. Next one says, and I kind of scribbled all over it, but a tangent line has to have two things that are the same. So I'm going to draw a little picture here. If I have a tangent line, two things have to be the same. The slopes have to be the same, but also they have to have the same y value. Okay, otherwise it's just parallel. So if my graph is like this, let me sketch up here. Okay, let's say that this is my graph. These are parallel at this point. Okay, but these are tangent because not only do the slopes match, but it's touching as well. So your two little arrows here were that they have to have the same slope and the same ordered pair. Okay? So whenever they're asking you to make something tangent, that means not only do the derivatives have to be the same, but the originals have to be the same as well. So look at your equation. It says you have this function. You're going to find the value of k so that it's tangent to this equation. So two things are going to have to be set equal, the derivatives and the originals. Okay, so let's set both of them equal separately, and then we'll pick which one we want to solve first. So I want x squared minus kx to be equal to 4x minus 9. I'm setting the originals equal. And then I also need to set the derivatives equal. Usually, yes. In this case, I think it ends up not really mattering too much because you're going to have to do a substitution either way. So what is my derivative on this side? 2x minus k. And then my derivative on this side comes out to be just 4 since it was linear. And then from there, you can pick if you'd rather solve for k or for x. What is going to be easier, though, for me to solve for? K. And the reason why is because in here, I only have to plug in k once, versus if I was substituting for x, I'd have to plug it in multiple times. Okay? So my 2x is going to move over. Now it's going to be negative k equals 4 minus 2x. And then my last step, I'm going to change all my signs, so it'll be a minus 4x and a plus 2x. And then remember, the goal with that is that you would take that, go back, plug it in there. So I'll have x squared minus, and then where my k goes, I'm plugging in a minus 4 plus 2x.
Does it count to show where it can be automatically distributed?
That'd be fine. That'd be fine. So I have x squared here, minus negative 4 is a plus 4, and then also remember I have this x over here, so that's really a plus 4x, right? And then on my 2x squared, it's going to be a minus 2x squared. Okay, so remember that you're actually kind of distributing from both sides. You have an x on one side and a minus on the other side. Okay, from here, x squared minus 2x squared is negative x squared. And then if I have a 4x on this side and a 4x on the other side, what's going to end up happening there? Yeah, when I minus my 4x across, it's going to end up eliminating. Which means that negative x squared is equal to negative 9. So positive x squared equals positive 9, which means that x equals what? Plus or minus 3. Okay. Then from there, that means that I have two possible k's. So if x is positive 3, what would k be? We're coming back to right here. So it'd be negative 4 plus 2 times 3. That'd be k is 2. And then my other ordered pair would be if x is negative 3. Then my k would have to be, let's plug that in, negative 4 plus 2 times minus 3. What would my k be? Okay, now, from here, what I would recommend doing is making sure that those equations are really tangent. So what I'm going to do is I'm just going to type them in since I have a calculator right here. The other option would be for you to go back and plug them in and make sure that they... Actually, let's do it by hand just in case. Okay, so plug in, our x is a 3, our k is a 2. Plug in right here. I'd have 3 squared, put it down here. Okay, so I'd have 3 squared minus my k is a 2 times 3. I'm plugging into my f. Okay, that's going to be 3. Then also plug it in here. So I'd have 4 times 3 is 12, minus 9 is 3. That one's a check. Okay, so I'm now going back to plug in the originals to make sure the y values really match. Okay, then let's check it for the second point. I'm now plugging in here, but I'm plugging in my second combo, which was a negative 3 and a negative 10. So it'd be negative 3 squared minus negative 10 times negative 3. Okay, and then on this side I'm plugging in 4 times negative 3 minus 9. Are they? So negative 3 squared would be 9. And then that'd be like a minus 30. What's 9 minus 30? Negative 21. And negative 21. Okay? So both of those came out to be fine. But sometimes you'll find the points where the slope match, and then you'll go back and see that maybe it was parallel, but it wasn't actually touching. So you may want to go back and check. You don't have to if it's multiple choice. You can probably figure it out. Okay?
Wait, so they both work?
They both ended up working because for my f of x and my y, when I plugged in those unique combinations, they came out to give me the same y value. This one gave me 3 and 3. This one gave me negative 20 and negative 21. Okay? Alright, next one says, write an equation for the line tangent to the function at its x-intercepts. How do you find x-intercepts? Set it equal to 0. So to find my x-intercepts, you're going to let 2x squared minus 4x equal 0. What can we take out? 2x. Which means my y value would be, or I'm sorry, my remaining part would be x minus 2, right?
Yeah.
So what are my two x-intercepts? 0 and 2. Now, keep in mind that if I have two x-intercepts, I need to write two equations for two different tangent lines. So I'm just going to pick the more interesting one. Okay, say we're picking x equals 2. What else do I need? A point and a slope. Where do you get the point from? Plug into the original. Okay, now usually on the AP test they would have labeled this. So it'd be 2 times 2 squared. Okay, and what does my y value come out to be there? 0. And then after you find your y value, you also need your slope. That means you're going to have to take the what? Derivative. Focus, you scrub. 2 times 2x is 4x, and then minus 4x derivative is minus 4. And then remember, that's the slope at any point. We want the slope at our point, so we're going to plug in 2. It is, yeah, minus 4 right there. Oh, yeah. It is. Okay? Then 8 minus 4 gives us 4 for the slope. So then we have our point, we have our slope, we can write our equation. So it'd be y minus 0, 4x minus 2. Okay? Now, you could go back and find the other one, but that's kind of easy, so we're going to move on.
Yeah.
But remember, tangent lines, you need a point, you need a slope. Okay, go ahead and turn the page.
We call it pitch.
Nope. You haven't even gotten your little cookie yet. Did you feel sad about that? Okay, let's do number 5. it says the graph of f of x crosses the x-axis at one point between 1 and 4. What is the instantaneous rate of change of f at this point? So, two things. When it's crossing the x-axis, that's a what? That's an x-intercept. How do you find an x-intercept? You're going to set it equal to 0. Good. Okay, so let's start with that. Okay, then from there, you want to know the instantaneous rate of change. That is the same as a what? A derivative or a slope. Very good. So they're asking you, find the x-intercept, and then take the derivative and plug it in. Okay? So if I were to set this equal to 0, first thing I'm going to do is add my 1 across. And then what to get rid of the e? ln both sides. Okay, so e and ln cross out with each other. Okay, so here's the problem. The x value you said is correct. You said 0, right? But is that between 1 and 4? So that is, remember, sine's going to have multiple places it happens. They're not letting you pick the easy one. Okay? So e and ln cross out. I have sine x equals. And then what is the ln of 1? 0. Good. So when else is sine 0? It is 0 at 0. Where else? Pi. So I have to pick pi because that's on the interval from 1 to 4. It does also happen at 0, but I'm not allowed to pick that because of the interval they gave me. Okay, so from here, what are you going to do? Find the instantaneous rate of change, which is a derivative, then plug in pi. So I'll give you a second to do that. No. Such a small obstacle, and you're going to drop over that. Really?
Can't say stuff like that, Sean.
Swimming post.
I never
Yes,
said
you did.
stuff.
Yes, you did. Yes.
Jordan, I would never say that.
Yes, you did. Twice.
I told Sean to politely end his life.
I didn't want to do it rudely.
Okay, I'm watching 13 Reasons Why. And I'm going to call back.
Wag. You see season 2? Yeah.
Well, no, I heard season 2 it gets sad. I mean, it's already sad. We're videoing people, okay? I'm on like episode 4, and literally I already know all the secrets. I don't even have motivation to finish it anymore.
You should have waited until you watched everything for like dogs. I'm gross.
It's been making me so sad, honestly. Oh, okay? Alright, so what is the derivative? Let's see if you did it right.
Cosine of x times e to sine x.
Okay, stop, be sweet. So, e to the sine x, and then the derivative of sine x is, okay, come back, come back.
It's e to the x times x prime, right? Or e to the u times u prime?
Yes. So it'd be e to the sine x, but then the derivative of sine x is cosine x. What about the minus 1? Derivative is 0. And then we want the derivative at pi. So what is the cosine of pi? Yes, some of you know. Negative 1. And then e to the, what is the sine of pi? 0. E to the 0 is 1, multiplied by the negative 1 in the front, it's going to be b. Okay? And then keep in mind, if you're forgetting your trig, I'll reteach it to you, but you got to know it at least somewhat, or else multiple choice you're going to be hurting. Now, keep in mind, if it was free response, could you have left it like this? Yes. Okay, if it was free response, this would have been good enough. Okay? Alright, go down to number 6. Read it. What are they asking you to do? What is the approximation for f of 0.5 found by using the tangent line to the graph of f?
They want you to find the tangent line. They want you to plug it into x.
Yes, okay. So we need to write the equation of the tangent line
And then plug in the number, right?
and then plug in 0.5. Okay, so keep in mind that they're giving you the same instruction, they're just scrambling it up differently so that you'll forget what you're supposed to do, but you know what to do. What two things do you need for the equation of a tangent line? Now, what is the x for my point? Is it 0.5?
No, you gotta plug it in.
No, it's you.
Zero. Because remember, my tangent line will be at 0, and then I'll be plugging in 0.5.
Sounds right.
Okay? So, f of 0 equals,
I appreciate
okay, e to the 0 plus 3. What's e to the 0?
1.
Plus 3 is? Square root of that is? So 0, 2, that's my point. Okay, next thing I need is my slope. Remember, for a slope, you're taking the derivative. I'm going to rewrite f of x like this. Yep. If it's a square root, that means really it's to the 1/2 power. So take the derivative. You're going to have to use chain rule. And then plug it in and do the rest. I'll bring you a cookie. Okay? You can do it.
Actually, miss, I do.
Okay, make sure that you're doing chain rule or you're going to get it wrong.
Wait, so if we turn in the homework 60 stuff before the exam, it's not late?
No. It's due on Thursday by then. Why are you saying that?
Because, miss.
You need it to be crunch time so that you'll find it's late if you don't turn it.
Uh-oh.
Is that what you want?
Turn in tomorrow? Or are you crazy? At the earliest, you'll get it Thursday.
Would you like to?
Can I get two? Hey. I like the tutor.
Okay. You're doing the problem though.
Yeah, of course.
Okay.
He's not, miss. He's copying me.
What?
What'd you get? Take your derivative. Okay, now plug in your x value. And then that'll be your slope. So you're plugging in 0. Yeah. You're so welcome. Okay.
It's just 1/2 equal to x.
Oh, you take 2.
Plus 30 times e to the x again.
Oh, yeah.
No one? Okay, now plug in 0 and that'll be your slope.
How am I going to find that out? Yeah, 1/2 e to the x. Or I just put 1 over
Or 2.
Thank you.
No,
I'll take 2. Thank you.
Bro,
You're welcome.
you need to get this chewy comment. I'm telling you to chewy.
No, the crunchy is the best.
No,
Yeah,
the
chewy.
chewy.
I agree with you.
The chewy.
These are better than Oreos in my opinion.
No.
You have to understand, I almost fought Marcel on this. You have to understand.
You should like buy. No, thank you. You should like.
See, if you got chewy, everybody want them.
You have to understand, I almost fought Marcel on this because he was like the country guy, like you
No,
are
it's
so.
chewy.
I almost fought
You
Marcel.
should buy the crunchy and the chewy.
Chewies are the best.
Take
The
that
fact that you almost got into a physical fight over what kind of
Because
processed bad
You get that too?
is the
You
same.
trying to throw him?
I'm not trying to throw anything.
Marcel was being very disrespectful. I'm like, he was like, forget you. He didn't use forget you.
Disrespectful of your position.
He's
Yes.
Okay.
my position to live.
Okay, politely though.
But like in your life.
Totally do it. No bother.
So listen, your 1/2 moves down. Then when you take away 1, now it's to the negative 1/2. What should you have times by in the back? E to the x. And then when you sort it out, it would have been 1/2 e to the x gets to stay on top, and your square root e to the x plus 3 moves down. So if I was going to organize it, that's how I would have written it. Okay, your negative 1/2 moves down as a square root with the 2. Your e to the x stays on top because it's not negative. And then from there, you're plugging in 0. So I have 1 e to the 0, 2 e to the 0 plus 3.
2 is 1/4.
Good. So on top I have a 1. On bottom that's 1 plus 3, which is root 4. 2 times root 4 is 2 times 2, which is 4. Okay, now remember, what was the point of all that crap? We need to write,
So you find an approximation.
yep, we need to write the equation of the tangent line. So it'd be y minus 2 equals 1/4 x minus 0. And then we're plugging in 0.5. Now, with your fractions, you can change them if you want to. I'm going to leave 1/4 as
2 and 1/8.
1/2. So I have 1/2 of 1/4.
2 and 1/8. That's it's C. X receipt.
Okay, let's think about, so if you were to do, okay, just relax.
I am right.
Okay, 0.25, half of that would be 0.125, right? And then to get rid of the -2, we would have to add it across. Okay? Down here, so we took the derivative, and when we plugged it in, the root of 4 is 2, and then you already had a 2 in the front from the 1/2. Yeah? Because you have your half, and then your e to the x stays on top. You got it? Okay, cool. So it should have been C. Okay. All right, turn the page. Okay, I really want to get to the integral one, so will you skip to number 10? We'll come back if we
How much more time do you have left?
have time, like 10 minutes or so.
What time is it? 4 minutes?
Yep. Okay, so look at number 10. Okay, because a lot of the other stuff we kind of,
Actually, I remember doing this.
Good.
I don't remember how to do it, but I remember.
Okay, so it's a piecewise function. Your breakpoint is 0. And it asks you to find the slope at 0. So what you should remember is that you can only take the slope of a function if it's continuous. So the first thing for you to check should be that when you plug in 0, top and bottom, they have to come out to be the same. Okay, if your graph is disconnected, you don't even have a slope at that point anyway.
They are disconnected.
Okay, so let's see. So the first thing that you would write is the limit as x approaches 0 from the left of h of x, and then I'm going to plug in 0 to the top. So it'll be 0 to the 4th plus 3 times 0 equals 0.
Are we going to have a formula sheet or anything for just? Yeah. So,
Okay, then x approaching 0 from the right of h of x is going to be e to the 0 plus 5, which comes out to be 6. If those don't match, you don't do anything else, you're done. Okay, you would say, therefore, h is not continuous at x equals 0, then it is not differentiable. So h prime of 0 does not exist. Now, if you had taken the derivatives and jumped right to that step, they actually come out to be the same, and you would have gotten it wrong. So you have to check that first. Don't get ahead of yourself. Take the derivatives and see if they match. If those y values aren't the same, then you don't have a slope to begin with. You don't even have to check that. Okay, now part B is where I want to kind of sit for a minute. This is a piecewise function. I want the integral from -1 to 3. So if I want the integral from -1 to 3 of h of x, we have not done one like this in class yet, but we will eventually. You're going to have to break up around your piecewise.
second one is 0.
Yes, so you're going to have to break up from -1 to 0. What function would you have been touching in the graph until 0?
Top.
The top one, x to the 4th plus 3x. And then for the second half, from 0 until 3, I would have had to switch to the e to the 3x plus 5. And the plus 5 is not little. Okay? So remember that if you have a piecewise, okay, they're not graphing it for you, but you should know in your head that if I'm switching functions, I need to split my integral up just like under a cusp region. Okay? So, left antiderivative, what's it going to be?
What's it? X to the 5th plus 2x.
3/2 to the x squared.
Good. Okay, then we're going to plug in 0 and -1. Okay, f of 0 is just going to be 0. And f of -1, I would just keep track of your sign. -1 to the 5th is going to come out to be what? So -1/5. And then -1, if I square it, is going to come out to be positive. Okay, so then from there, what are you doing? Top minus bottom. So it's 0 minus a fifth plus 3/2. Is that right? What did I miss?
You didn't do the other thing, the other side.
Well, okay, yes, but you also have to have parentheses. Okay, because remember that minus is applying both to the negative a fifth and to the 3/2. And so if you don't put those there, it's going to be wrong.
What if you just do it in your head?
I mean, if you distribute the negative, then that's fine.
Yeah, I mean, if you distribute the negative in your head.
You understand.
If you distribute it in your head, that would be
I
fine.
did that on the test.
I like how no one else got the bracket.
Okay,
Because you always.
you just bring up old stuff.
Alright, I'm done.
If you take out that test, I will show you why it was wrong.
I didn't
You gotta let stuff go. Okay? You gotta move
Except
on.
the fact that you did these brackets.
So-
But you did just say we could do it in
Oh
our
my
head.
god. You'll just accept
Okay, so his situation's totally separate, and I'm not gonna waste time on it right now.
But we could, so it'll be fine.
So if you skipped this and went to this, that would be acceptable.
Yeah, I do work on
Okay, not putting brackets around your antiderivative and having numbers randomly scribbled to the far ends of your paper, that is not what we're talking about.
They all ended up with the correct answer.
But you didn't
Anyway.
put brackets.
It don't matter how it gets the answer, it gets the answer. I try
Okay.
to explain that to them.
Whoa.
So, that is the answer for the first pocket of area. For the second integral,
They're very live.
okay, what are you gonna need to do? U sub, are you gonna need to do U sub on the whole thing?
There's 3 answers.
No, you're gonna have to split up your second integral into 2 pieces. Okay, so I would break this up into 0 to 3 of e to the 3x. And then I would have to split it up into 0 to 3 of,
Oh, you can't do U sub with the
5.
5?
because the 5 doesn't need U sub, but the e to the 3x does. Okay? So for my first little chunk, let's do that one first. What's your u gonna be? So we're working this integral. U is to the 3x. That means that du is 3 dx, which means that dx is du over 3. So when I rewrite my antiderivative, it's going to be the integral of e to the u du over 3. So I'm just going to put a third in the front. And so my antiderivative is a third e to the u. What do I still need to remember to do?
Put the U.
Change your endpoints or put the u back, either one. So I'm going to change them. If that's a 3, now it's a 9. And if that's a 0, then it stays a 0. So I'm ready. I'm going to come back over here to my final answer. I'm going to put plus. When I plug in 9, I have a third e to the 9 minus a third e to the 0, which would be, what would a third e to the 0 be? Just a third. So I'm not going to put the e to the 0, but you could. Okay, is my answer complete?
Why is it minus? What did I miss?
Because I do top minus bottom.
Oh, yeah.
So it'd be a third e to the 9 minus a third. Okay, am I done?
No.
One more integral left. Your 5, what's the antiderivative? 5x. Notice we're putting brackets around our antiderivative. Then we're going to plug in 3. We're going to plug in 0.
Like always say, we're not gonna bring it up, but you would bring it up.
Yeah.
No, not we. She brought it up. She said that we're not going to talk about that, but we put bracket on it.
I'm getting 100 on the next test.
You said that last time.
You say that every time, and then you forget to just bring it up.
It's a 1/3.
You said that for every test this year.
And then you forget to do one thing.
No, but then during the test, you're like, oh, this is hard, it's hard. Then I just say, like, oh, yeah. I'll
Okay,
thank you.
good. All right, turn the page. I want you to set up the next one just to make sure that you got it. Yeah, we're not going to have time to finish it all the way. Okay?
Who fell off a scooter?
Okay. Literally don't care at all about that situation. Okay, so to show that it's continuous, you would have to check that. Differentiable, you check it. Shh, no. Okay, for part D, you want the integral from negative pi to pi. Where would your breakpoint be? At 0. So from negative pi to 0, I would use which function?
The top one.
The top one, which would be
1 minus 2 sin x.
And then my second integral, I'd pick up at 0 and I'd go till pi. And then my function for that one would be e to the negative 4x. Okay, now, would I have to break up this integral into two pieces?
No.
No, what would your antiderivative be?
1
X.
X minus, what's the antiderivative of sine x?
negative 2 cosine.
So it'd be a
or
plus 2 cosine x, good. Then you'd plug in 0 and negative pi. Okay, when I plug in 0, that'd be 0 plus 2 cosine 0. What's cosine 0?
1.
Good. So if it's 2 cosine 0, that'd be 2 on top. Okay, then we're plugging in negative pi on bottom. Negative pi plus 2 cosine negative pi. Now remember, when your angle is negative, do you remember what you do?
Go the other.
Go to
You
the
just
far-
go backwards pi. So that's negative pi, but remember it's the exact same angle as positive pi because it's a full 180 degrees. So what's the cosine of negative pi or pi? Either one, because they're the same, negative 1. So this is negative pi minus 1. And then remember that when you write your solution, you have to subtract those two pieces.
Wait, wouldn't it be 2?
It would be
I
2,
mean,
thank you.
For the sum.
So 2 minus, okay,
Alright, good.
negative 2 minus pi. Now keep in mind, that's only your first integral. You still have to go back and do the second one by u sub.
Darn 2.
How do we get
Plus,
Darn 2. Ow. That hurt.
you'll be able to do that.
okay,
Thank you, sir.
good.
Not twice.
Okay, so your u would be what? Okay, what's your du? Okay, antiderivative or dx would be du over negative 4.
Dude, I didn't fall.
And then you would rewrite, okay, tell us after. I care about it
I'm
after.
not even worried about the story.
I want to know more. E to the u, du negative a 4th. And then my upper value, if I'm plugging in a pi, that'd be a negative 4 pi on top. But when I plug in 0, it would stay at 0 because it's just 4 times 0 is still 0. I don't think, no, you're not, it's going to work out to be fine. So I'll have integral of e to the u is still e to the u. I'm going to put my negative a 4th on the inside. So when I plug that in, I'll get negative a 4th
That's
e to the negative 4 pi.
Then we gotta, wait.
This one will be negative a 4th e to the
You
0.
gotta, do the not the things. You gotta, since you're a use of rule.
So I did change them. It was originally a pi, so
Oh,
now it's
oh,
a 4 pi. And then remember, you do this minus this. So you'd have negative a 4th e to the negative 4 pi minus negative, you could change it to a plus a 4th. And that's, Yoel, what I was trying to say with, if you want to change the sign on that in your head, instead of putting parentheses, that would be fine. So if you want to say like, oh, it's minus and negative and switch it, that's fine. Now, what did you mean by change your order?
Like, since it's not.
Since it's backwards, I would say just don't worry about that. The reason why is that this e to the 4 pi is really on the bottom, so this fraction is actually smaller than a 4th. So it comes out positive. It kind of all works itself out. So I wouldn't worry about that. You could do that and it wouldn't be wrong, but it's kind of unnecessary work. Okay? So her question was, do you have to reverse it because this integral is backwards? The answer is no. I just keep it all in the same order. The only time you really have to think about switching it is when you're doing area.
I
Okay?
agree, miss.
And you would just leave it ugly. Okay? Good job. Okay? You did a great